Hey there, this video will review factoring in the following four scenarios as you see them here. Okay, the first one, greatest common factor. So we have two examples to get through here. Okay, in the greatest common factor scenario, you're always going to have one set of parentheses. So let's look at the first example. Let's write out one set of parentheses. What you want to do is you want to find the greatest common factor of all the terms in the polynomial, and that's what's going to go outside of the parentheses. So the greatest common factor is what goes outside of the parentheses. So let's begin with each individual term that makes up this polynomial. What's the greatest common factor of 32 and 4? Well, that's just 4. What's the greatest common factor of x squared and x to the 5th? That is x squared. As a rule of thumb, whenever you're factoring out variables with exponents, the greatest common factor is the variable with the lowest exponent. In this case, it was x squared, so that's the greatest common factor of x squared and x to the 5th. Okay, now, remember, factoring is just breaking up the terms. So, ask yourself, what do I need to multiply 4x squared by to get 32x squared? Well, I need to multiply it by 8. 4x squared times 8 gives me 32x squared. And what do I need to multiply 4x squared by to get negative 4x to the 5th? Well, I already have the 4, so it's going to be negative. So it's going to be 4 times negative 1. And x squared times what is going to give me x to the 5th? That's going to be x to the 3rd. So that's my final answer. My final answer is 4x squared times 8 minus x to the 3rd. That's my final answer. And look, you can always check that that answer is right by just distributing the term on the outside and making sure it goes back to the original. Okay, let's try the second one. So again, you need one set of parentheses. So there's my one set of parentheses. And you just want to factor out the terms individually. So let's start with the 30 and the 10. Greatest common factor of 30 and 10 is 10. 10 goes on the outside. The greatest common factor of x squared and x to the 3rd is x squared. Remember I said whenever you factor out variables with exponents, the GCF is always the variable with the lowest exponent. Now notice something. This term, 30x squared z squared, does not have a y to the 3rd. So you will not factor out y to the 3rd. So what's the greatest common factor of z squared and z to the 3rd? That's z squared. Okay, now, this requires a little thinking. 10x squared z squared multiplied by what is going to give me 30x squared z squared? Well, that's just going to be 10x squared z squared times 3. Okay, and you can just check it by making sure that this multiplies to give you this term here. Okay, now, the second term inside the parentheses. Let's just do it term by term. 10 times what gives me positive 10? 10 times 1. x squared times what gives me x to the third? X squared times x. There's a y to the third here. There isn't a y to the third on the outside, so I can just write a y to the third here. 1, it's like saying 1 times y to the third gives me y to the third. Then you got z squared multiplied by something has to give you z to the third, so that's z squared times z. So your final answer is 10x squared z squared, open parentheses, 3 plus x y to the third z. That's your final answer. And you can always check by distributing, making sure it goes back to the original. Okay, the second scenario we're looking at today is difference of perfect squares. And, you know, most of you have seen these before. I'm just going to do like a quick review on them. So you need to write 2 sets of parentheses. Factor the perfect squares by finding the square roots. So you got to factor out x squared and -9, and you do that by just finding the square roots. So you're going to get x minus 3 and x plus 3. Where's my x plus 3? There it is. So that's the answer to the first one. The second one, again, write 2 sets of parentheses. Factor the perfect squares by finding the square roots. So the square root of 25x squared is 5x. The square root of 16 is 4. So you're going to get 5x minus 4 and 5x plus 4. And I did forget to mention that the signs in the middle should be opposites. But it was written down. Okay, and the last one, so you got your 2 sets of parentheses, factor the perfect squares by finding the square roots. The square root of 9 is 3, so you're going to get 3 and 3 here. Square root of x squared is x and x. And then the signs in the middle should be opposites. Now I want to point something out here. This is not the same as this. Okay? Okay, now, one last thing. How do you check if you got it right? Just FOIL this out. Make sure it comes back to the original. That's how you check if it's right. Okay, third scenario. Trinomials where a equals 1. Again, most of you have seen these. This is just a quick review. So you're going to write 2 sets of parentheses. Now, you got to find the factors of c that combine to give you b. So if you recall, the coefficient of x squared is a, the coefficient of x is b, and this is your c. So you're looking for the factors of -24 that add up to -5. That's what you're looking for. So before we look for that, let's just write x and x here, because x times x is going to give you that x squared. So what are the factors of -24 that add up to -5? So you just start thinking, you know, you write 24, you just start listing out the factors. You know, 24 times 1, that won't do. 6 times 4, that won't do. And then you finally get to 8 and 3. And you know 8 times 3 is 24. Whoops, it's supposed to multiply to -24. And so if you make the 8 negative and the 3 positive, this negative times this positive gives you -24, and then this negative plus this positive adds up to give you -5. So your factors are -8 and +3. So you get x minus 8, and you get x plus 3. Okay, so these two terms, the negative 8 and the plus 3, they have to multiply to C and they have to add up to B. And if you want to make sure that you got it right, you can just FOIL it out. If it comes back to the original, it's correct. Okay, the last one. I know it's been long. Factor by grouping. So what you want to do in factoring by grouping, so you're going to have 4 terms in factor by grouping. You're going to have 4 terms. You want to split them down the middle, and you're going to write 2 sets of parentheses. So we're going to use greatest common factor to factor out what's on the left of this line. So what's the greatest common factor of x to the third and negative 3x squared? That's going to be x squared. Right? That's the greatest common factor of x to the third and x squared. X squared times what gives you x to the third? X squared times x. X squared times what gives you negative 3x squared? X squared times negative 3. So on the left side, we got x squared times x minus 3. Now, on the right side, you're going to factor out a negative 6, because that's the greatest common factor of these 2 terms. So you got negative 6 times x gives you negative 6x, and then negative 6 times negative 3 gives you positive 18, because a negative times a negative is a positive. Now, what you will do is you're going to group. Here's what I mean by that. The x minus 3 and the x minus 3, that just becomes one set of parentheses as x minus 3. And the x squared and the minus 6, the coefficients of the parentheses, you'll join together in a set of parentheses. So you get x squared minus 6. That's the final answer. Okay, just one last thing. I want to do a what-if scenario. What if, so you know the way we factored it. We said this was x squared, and this was x minus 3. Okay, now when you get here, what if instead of factoring out a negative 6, you factored out a positive 6? Then you would have, inside the parentheses, you would have negative x plus 3. Can you still group the x minus 3 and the negative x plus 3? Well, yeah, I mean, you can, but I'm going to caution you here. You should always try to make what's inside the parentheses the same. They should be the same, and if they're not the same, then you should play around with it and make it the same. So you see, if you did that and you didn't have the same thing on both parentheses, then play with it. Instead of making the 6 positive on the outside, try making it negative, and then see where that gets you. And then you'll see that it'll get you the same thing as the other one. Negative 6 times x gives you negative 6x, and then negative 6 times negative 3. So just play with it and make sure that what's inside the parentheses is the same. All right, this was a long one, but we had to review a lot. I hope this video helps. Take care.